Does anyone remember what a trapezoid is? Or a trapezium in Australia? It's a four-sided shape with two parallel sides. Very good. So we're going to learn a rule that involves a whole bunch of trapeziums. So when we started integrals, I showed you this. You can use the integral to find the exact area under a curve, or you can just add up all the little rectangles under the curve. I guess they're not really under the curve. And as you make the rectangles a smaller width, what happens to the area? It gets more accurate. So the smaller the width, the more accurate the area. We're kind of shifting away from integrals for a moment, going back to just like shapes, essentially. Okay, it's just a different way to find the area under a curve. I don't know. So you can see here's an example of trying to get the area under these curves using just rectangles. So you get the height. That's the height of the rectangle. And the width is, can you see what the width is for all of the rectangles? 0.5. So you're taking the height, whatever the y value is, and timesing it by that width to get the area. You guys remember length times width for rectangles? Do you remember? Oh, there's the rule. Did anyone see it? What's the area rule for a trapezium?
It's like half AB times H on 2.
Very good. What's the AB? That's the A, that's the B, and the H is the height. So in this, what's the H? In the graphs. It's the width. It's the X value for each rectangle. Okay, so we're going to use 0.5, or we're going to use 1 for the height. It's always 0.5 or 1. Or 2, something like that. And then the A and the B, what are those on the graph? If this is the trapezoid here, that's the width. What's the A and the B? The two y values. Okay, so there's the really long version. The integral from a to b is approximately equal to the change in x, which is the width, divided by 2. See how we've got a half dividing by 2, and these are all the a's and the b's. I think the reason this is useful is if it's a very, very complicated graph and you don't want to integrate. I think that's where it's useful. But it's not very commonly used. Why is there a 2? Good question. So this is the first y. You guys listening? Shh. This is the first y. This is the trapezium. The first y plus the second y times by the width divided by 2. Then we've got the second y plus the third y. So see how we've got 2 of the second y? Because you're adding all of the middle y's twice to get all of the trapeziums added together. It's only the end y's that you have one of those. So the end y's, you only have one of those because you only count them once. So where do you think we start? It doesn't specify, so I'm going to specify. I'm just going to make it easy. Just a width of 1. So how many are we going to have? 2. So a great way to do this is to make a table. So when x equals 0, what's y? 0 take 2 squared times by negative half becomes negative 2 plus 12 is 10. Yeah. Good job if you got that in your head. 1 minus 2 is negative 1 squared is 1 times a half. What's this one? And then this one, 2 minus 2 is? 0. So that's 0, so it is? Question. Okay, so if we did the integration from 0 to 12 for y, let's do the rectangles first. So what would be the rectangles? Base times height. What's the base? There's 2 rectangles. 1, and what's the height? You do the highest one, which is 11.5. Thank you. Okay, so we found using the rectangular rule that the area is 23.5 units squared approximately. Okay, let's see if the trapezium rule gets it a little bit closer. This is the trapezium version. So you do the width divided by 2 times by, so we're going to do y1, which is 10, plus 2 times y2 plus the end y1. Sorry, the end y, which is 12. So a little bit more complicated. There you go. So the trapezium rule got slightly more accurate answer. So that's not including, it's not including that area over here. So we've turned it into trapeziums. So it's just this area in here for the trapeziums. But there's still slight little gaps that we're missing. So that's why the integral is the most accurate. There you go. So if we integrate, you would get apparently 22.66. All right. That's my first recommendation. Draw a table. Table is x's going up in terms of the width from 0 to the final. So it's going up in ones. That's why. Yeah, so if the width was 0.5, you would go up in 0.5s. So it would take you a lot longer. That's why I changed to just widths of 1. Okay, so hopefully most of you have got the y's now. So now you sub those into the trapezoidal rule to get your approximate area. So the integral from 0 to 4 in terms of x is approximately equal to the width divided by 2 times by all the y's added together.